Welcome, students of astrophysics, to my briefing on gravity, a new postulate. I am Professor Harold Kreitlein, Senior Professor of Astrophysics at What's-A-Matta University, popularly called What's-A-Matta U, in Frostbite Falls, Minnesota, where I hold the R.T. Squirrel Chair of Astrophysics. Now, let me start out by making sure we all understand science is theoretical. It's not fact, it's not truth. It's made up of postulates and theories. Each postulate or theory has an associated degree of proof with it. But ultimately, any theory or postulate may prove to be incorrect. That is science. Any scientist that tells you this or that is true, is fact, is deceiving you and should not carry any weight in your mind. Okay, now, my proposition is a new theory on the nature of gravity. I'm going to present this in simple terms. I'm writing a paper for the International Astrophysics Association, and I'm waiting peer review from leading theorists. I need to cover a couple terms and definitions. I'm going to talk briefly about the Big Bang, the Planck era, expansion, dimensions of our universe, existence, space-time, and the conventional wisdom on what gravity is before I tell you what my theory is. Now, before the Big Bang, there was nothing. Now, nothing is a big word, and we could spend a month just, mentally exercising our brains on what nothing means. But for the brief purposes of this, it means there was no existence, no time, no space, no physics. There was nothing. People ask me, well, how long did nothing last? Well, it didn't last at all. There was no time. There was no infinity to nothing. It just wasn't there. Nothing was there. It's a hard concept to grasp for us, but if you spend a little time thinking about it, you might feel comfortable with it. But that is nothing. There was nothing before the Big Bang. Now, why the Big Bang? Well, there's a lot of theories. Some people theorize that universes in different dimensions act in waves and they banged together and created the Big Bang. I don't know. We don't know. We're not sure. Perhaps we'll never know. But when did it happen? We theorize about 14 billion years ago. But when the Big Bang did start, when it did occur, in the middle of nothing, which there is no middle of nothing because there is nothing. But anyway, the Big Bang started space, time, energy, matter, and infinity. But most importantly for us, it started existence. Now, the Planck era was the first tiny little bit after the Big Bang. 10 to the minus 43rd seconds after the Big Bang. In other words, 4 point and then 43 zeros and a 1. That's how long the Planck era was. A tiny, tiny little bit. We don't know anything about it. And really, it's indescribable. We don't believe the laws of physics that we know today operated then. But that was such a tiny, itsy-bitsy amount of time. But anyway, it is important. Some scientists spend their whole career trying to theorize what happened in that first tiny little bit. Well, let's look here at this timeline. We see the Big Bang at time 00, the Planck era, but along came energy and matter. Then it exploded into nothing that was out there. Nothing was out there, but it expanded into it, coalesced into the stars and galaxies, and then we have the Earth 13 to 14 billion years later. More expansions continuing, and then long into the future, 100 quadrillion years from now, there'll be dark times when we all drift away from each other as the universe continues to expand, if that's indeed what happens. Well, this is the first second. I've divided this into a couple little things. This is the first second of time. All of this. The Big Bang at time 0, 0. The Planck era, 10 to the minus 43rd. At some point, 10 to the minus 24th, energy and matter were created. And then the expansion took over. And it exploded out into the nothingness that wasn't there. Anyway, funny, isn't it? Well, expansion was important, and it's still going on today. Once again, you could spend an entire career studying expansion, the expansion of reality, the expansion of existence. And it's not just a simple matter of like a balloon blowing up. A lot of people think of expansion as a balloon, but no, everything, every particle, every tiny little bit of everything inside is all expanding. So it's quite complex, really. Now, there are dimensions of our universe. We generally walk around in 3 dimensions. You know, breadth, length, height. Those are the 3 conventional dimensions of our universe. But we also recognize a 4th, and that is our existence. Our existence is like a 4th dimension, carrying us through space and time. And that's what really ties space and time together. Physicists, astrophysicists, talk in terms of space and space-time continuum because they're related. Time and space, they're together. Now we exist within that, within those 4 dimensions. Those are the definitions of our existence. Those define our existence. Space and time, energy, matter, the law of physics. The bottom line is things are in this universe. Space-time is interwoven, it's linked, it's inseparable, and existence occurs within space-time. Now, we recognize at least 4 forces, gravity and the 3 other nuclear forces. And you can go and search those on the internet or read about them. But they are what hold everything together in our existence, in our universe, within our 4 dimensions. Now, the conventional wisdom on gravity is that it's produced by gravitons, a hypothetical quantum of gravitational energy regarded as a particle. Okay, that is what has been considered the current theory or the popular theory. And I reject it. I do not believe in gravitons. They've never been seen. Tests have been run, experiments, all sorts of effort has been made to try to identify gravitons. They never have been seen. They've never been localized, examined. And I believe that they never